Okay, so let's start today's session, and let me share my screen. Cool, visible, right?
Yes, sir.
Awesome. So now today we are going to learn the architecture thing. What is architecture? What is MVVM architecture? What is view model? What are use cases? Those things we are going to cover today. And one quick things is based on the poll that I shared in the community group. So we are going to take a break for 5 to 10 minutes after an hour. So that will provide a bit of refreshment for you as well. Cool. So let's start today's session, and we will understand the architecture as well as what is the architecture actually. Why do we even need these things? So before we learn these things, this is second week, right? So let's create a new module for the second week. So I'll go to the file, new module, and for this week, let's call it a week 2. Okay, week 2 language is Kotlin, minimum SDK is a Nougat, and in the last week we have used the Groovy DSL, right? So this week let's use the Kotlin DSL. Let's go with uh, Compose, or what are this week's topic? Kotlin, these things, and Hill, right? So okay, what do you want me to go with these things? Because there won't be much UI, it will be just a concepts. So should I go with compose or views? Whatever you folks says, I'm fine with both. Hmm, compose. Okay, let's do one thing. Yep, let's go with the view, because compose is something some of you don't know, right? So it would be a problematic. So let's go with the view, empty views activity, and let me create a new activity. Let me add it to the Git. Okay, let's build the Git. And now let's go through the project structure. So first I'll explain the KTS things as well. So for those who don't know about the Kotlin scripting may have an idea. A window inset, we don't need it. Edge to edge, we don't need it. Let's remove these things. And yes, so our week 2 module is created and it is here, and we have a pretty simple main activity just like what we have in week 1. Now for the week 2, this is a build file, and for the week 1 you can say it is build.gradle. For week 2 it is build.gradle.kts. Okay, so what's happening is this Android Studio is using the version catalog, right? Let me explain it without version catalog. uh, Let me just, oh my god, why do I need to download it? Mm. Okay, cool. Let's have a look at these things. So this is module 1, and this is week 2. So this is a Groovy based build file. This is a Kotlin based build file. So if we compare them side by side, let's do so. This one is let's move split right, right? This is one, and okay. So this is a Groovy based build file. This is a Kotlin based build file. Okay. So plugins block is same, as you can see. This is alias. This is coming because we are using a version catalog. I'll explain the version catalog as well later. But this is the how syntax looks like, and this is the Android syntax. And the major difference is how the syntax works. For example, in a Groovy, to assign a variable, you don't need to, you just can use a space, right? But in a Kotlin, to assign a value to a variable, you need to use a equal to. So that is something we are doing here. Similarly here, this is a default configuration for the application. Okay, for example, what is application ID? Application ID is essentially your package name, but especially for the Gradle. Okay, build system. What is the minimum SDK? Minimum SDK means what is the least Android OS that you want to run your app. Then there is something called a target SDK. So target SDK is something which Android version you are targeting. For example, let's say you wants to use the latest feature of Android 13. Okay, so Android 13. So if what you can do is you can set your target SDK equal to 33. That means you are targeting Android 13 as a operating system. All the remainings will work. For example, Android 12, 10, 11, 12, all these will work as well. The next is a version code and a version name. So the version code is the your sort of applications code, which version you want to publish. So once you create an application with version code and upload it to the Play Store, if you want to provide an update, you need to provide you need to at least increment the version code by one. You can, if it's a one, you at least you have to make it a two. If you do three, that is fine, but at least it should be plus one. Okay, so this is how version code works, and then there is a version name. So this is a strings for your own use. This is here you can something define anything whatever you wish, but ultimately it's for your own reference, that you can recognize that okay, this is the, for example, if you are publishing a snapshot version, so you can write something like this. Snapshot simply means that is something that is not yet released for public. Okay, so you can use version name here. There is this test instrumentation runner. So this is a runner. I'll explain runner when we learn the testing. So we are defining a runner, then we are defining a build type. So there could be a multiple build type. For example, a debug, we when we uh, when we are in the development phase, we will use a debug version. That is something, if you want to customize the debug version, you can customize it here. If you don't do it, Gradle will manage it for you. Okay, but this is how you can define it. And if you want to create a release version, that is this these settings will apply when you release your application for public, that is you upload on the Play Store. So if you want to minify the resources and code and all those things, you can use a minify enabled, and you can use a proguards as well. So proguard is a sort of a obfuscation technique. So for example, if I have used my class test class, my class, I have created a class called, let's say, main activity. Okay, so what proguard can do is it can obfuscate the code. For example, when you compile, when you build an application, it could rename it to something like ABC. Okay, so whoever decompiles, they may not have idea that okay, what is this ABC. Okay, basically it obfuscates the code. It does a lot more than this, but this is the simple thing. Now there is a compile options, how you want to compile it. We want to compile it against Java 8. Okay, if you want to compile it against the JDK 8, you need to use these things. Otherwise, if you want to compile against JDK 11, you need to use these things. And then you need to use a JVM version for a Kotlin. So this should be same thing. Okay, so we are assigning a Java 11, and JDK is probably, I believe everyone knows, right? I don't need to explain it. Cool. And this is one. Let's mark it as 11 as well. Cool. So now in the dependency block, you can see the syntax is pretty simple. Just that if you, this implementation is a function, right? It is a function. So in a Kotlin, we invoke function by a parenthesis, something like this. So we have to use it in a Groovy DSL. You don't need to do it. But basically, what we are doing is both of these lines. Let me show you. Both of these lines dot core KDX, and what is a version reference is a 1.12.1. so this is how we define it. So both of this one and these lines are the same. It's just that we are using a version catalog to define the dependencies. So version catalog is a feature that allows you to define a type-safe dependencies. For example, if I am using this version, okay, this is a, let's say, this is the version number that I'm using for a 5 dependencies. So if I do something like this, KTX, instead of, let's say, I write something like core Java, so I need to define this, all these things multiple times, right? Version and dependencies. So version catalog allow us to sort of a group dependencies, something like this, and then you can able to type safely access it. For example, you can access the KTX. So more on this probably later. but this is how essentially it works. So let's sync the project and let's run the project as well. So this is our main activity in a week 2, and let's run these simple things before we understand the architecture. Cool. uh mhm. Okay, it is running, right? Let me close the tool window activation. So yes, so this is Android Studio stable version. If you create a new project, then it won't use a version catalog probably. Let's use this one, right? Let's go with the Groovy DSL, that is most basic one. And this is how it looks like. This is your stable Android Studio. I don't usually use it, so that is why the font size and all those things are smaller. Mm, but if you don't want to play around with the betas and it could have a bugs, you can definitely go with the stable version. But here I'm using the canary version. Cool. So Kotlin, what to say? Kotlin DSL for a Gradle is clear, right? For everyone? Any question around it? Okay, cool. It seems no question. Uh, okay, cool. Then let's move on to the architecture part. So we will understand what is architecture, why do we even need these things, and how it works, and blah blah blah, those sort of things. Let me see these things. Yes, so this is the default setup, right? So this is how your build file looks like. Okay, so if you here, as you can see in the build file, we are using a version catalog. So this is how it looks like. Sorry, this one. This is how it looks like, alias and all those things. But if you don't use version catalog, this is how it looks. You need to define your plugin using a ID. The first is basically it's application, right? Android application. So you need to use a that plugin. And second is we are using a Kotlin for Android. So you need to define that plugin. The rest things are sort of same, right? Rest things are sort of same, and even the just the dependency is defined hard codedly, something like this. So this is the view that you will be familiar with once you start the development, or if you are doing it anyway, if you don't use a version catalog, this is how it looks like. The dependencies and declarations and all those things. This is how it looks like. Let me close these things because we don't need it anymore. Cool. Now let's focus on the architecture thing. Where is this? Yes, main activity. Cool. So what is architecture and how, why do we even need it? So let's understand with a bit of the diagrams. So before we understand, let's understand why do we even need these things. So let's say we are building an Android applications. Okay, so in week 1, what we did is we just wrote the code, the whole code ourselves, right? Something like this. We define a button, when we set the click on listener, whatever is happening, what action needs to be done, all those things, the codes will return inside the main activity A. Okay, for example, here we want to maintain a counter, something like this. So and this counters was defined inside a main activity A. That is your, sorry, that is your activity. And if you want to survive the configuration changes, we had to rely on the on restore instance and on saved instance state. So basically the essence is all the codes. For example, we were declaring a broadcast receivers here, right? And we were starting the services. All the code that we want our application to perform was written in the main activity. Okay, so this is what we did, and this is what people used to do earlier. Now, if it is a simple project, just like this one, if it is a simple project, then it's fine. You can manage it, right? It's just a few variables, 5 to 7 variables, and just a few of the on-click listeners and intent firing and all those things is happening. So this is a toy project, that is fine. But now the issue with these things is you there are few issues with these things. First things is reduce the readability. Okay, reduce the readability, and it reduces the maintainability. So what does it mean? Is the first thing is it is not clear what is the responsibility of main activity, right? It defines some views, it defines a counter variable, it defines the broadcast receivers, it starts the service. So it contains sort of it's a kind of a messy activity, right? It contains a lot of things. So the clear definition is not defined that what this activity is supposed to do. Okay, that is one thing. Second thing is it reduce the readability in the sense that I need to go through all these variables. The one is counter, one is Wi-Fi receiver, one few of the buttons. They are relatively not related to each other, right? Or to say they are not sort of what we want. So this is the issue. And another thing is a maintainability. Okay, it's not it's not a scalability and a maintainability. So let's say, for example, if you want to add a more features into the main activity, then we need to all if you go by this approach, we need to add all the codes here. That is whatever we want to do. For example, you want to show some UI, we want to show some button, you want to start some service, and then activity will become a messy. So in short, what will happen? Activity अपनी हो जाएगी पूरा कचरा, right? It's let's say it's item 1 and it's item 2, and all sort of things are happening in the activity itself. Okay, so activity हो गई अपनी पूरा एकदम कचरा. So that is something we don't want to do, and that is something that is not suitable for the large scale project, because in large scale project you need to keep an eye on maintainability, readability, scalability. What if tomorrow someone comes and say that, hey, please add this feature into this activity? So if you make it a messy something like this, then it's not going to work, right? And you will have to add a lot more effort to make it work. Basically, you need to stitch the features with this activity. So this is the reason we don't write code something like this. This is known as uh, a spaghetti code, something like this. Okay, this is known as a spaghetti code. To put it simply, it's a kachra. Okay, and we don't want to make a kachra here. So what we will do is we won't write code something like this. Rather, what we will do is we will organize our code in such a way that is by using which we will be able to recognize the code that, okay, this code does this code does these things. Just by looking at it, we will have an idea. For example, let's define some buttons in the activity, because this is where it belongs. If we have a counter variable, let's define it somewhere else. If you want to start a broadcast receiver, let's define it somewhere else. So basically we wants to organize our code. Okay, just like if your room is messy, it won't looks good, right? So if you organize the things on cupboard, the few things on a wall, a few things on around the table, then it will look nice, right? And you will be able to maintain the things as well. So the same happens with the code. You need to organize your code in such a way that allows you to improve the readability, maintainability, scalability, testability, all those things. So the intent here is to organize the code, and the organization of this code is known as a architecture. How you organize it? For example, to put it most simply, uh, for example, you let's say we only have a few items, okay, and let's say 3 items, and let's say this is two. Sorry, let's keep only 3. So how you organize the code is known as the architecture. For example, you place the item 2 at this place. I'm just giving you an example. You place the item 3 into the item 1, you place the item 3 into the item 2. So basically, how you organize the code, you move this code into other class. So how you organize the code is known as a architecture. By the simplest definition, architecture is how you organize the code. So architecture refers to the high level structure and organization of the software system. It defines how the different components of a system interacts with each other and how they are organized to achieve specific goals such as callability, maintainability, and reusability. Okay, so architecture is clear, right? So how you organize the organization of your code and resources is known as architecture. Now, based on how you organize the code, based on these things, we have various types of architecture. For example, if you keep item 2 inside item 1, or if you read some values from item 2 to item 1, or if you pass some value from item 2 to item 3. So basically, based on the different types of values you define, based on the different type of the path you take, we have a different type of architecture suited for specific kinds of applications. So now we are going to have a look at these things. Okay, so this is what architecture refers, and these are some architecture principle, but I'll explain it later. Otherwise, it would be too complex here. Cool. So this is architecture, and based on the how you organize the things, we have different types of architecture. Okay, so this is definitions we have seen. Yes. So usually, mainly we have around 4 to 5 types of architecture. The one being the MVVM, that is prominently used in Android model view model. Second is MVC, that is model view and a controller. The fourth is third is MVP, that is model view presenter. Fifth is a MVI, the is a model view and intent. And the fifth is a Viper, that is mainly used in iOS development. So we have a lot of type of architecture, types of the architecture, but we are going to mainly see the three things, that is MVVM, MVC and MVP. Okay, so let's understand these things, and then we will move on to the details of the MVVM, which is a prominent architecture pattern in Android development. Cool. So these are the full name, as you can see, MVVM for model view model. You can see model is a common, right? Model is common amongst all architecture patterns. So we will see these things. Let me open the uh, uh, diagram. I have one nice diagram. Architecture patterns, where it is. Uh, yes, this is cool. So we have multiple types of architecture pattern, right? Model, MVP, MVVM, MVVMC, and a Viper pattern. So let's talk a bit about the first pattern, that is MVC. So MVC stands for model, view, and a controller. So what is model, what is view, and what is a controller? So whatever the data you want to put it simply, whatever the data you want to store, or you are, whether it's you are storing it into the local database or you are retrieving from the network, the essence is whatever the data you are storing or retrieving is known as a model. Okay, I'm being very broad here, but this is known as a model. Whatever the data you are storing or retrieving is model. The second component is a view. So what is a view? Whatever your user is seeing and interacting is known as a view. For example, in our case, activity is what user is interacting, right? Activity is what user is interacting with. So in our case, activity is a view. And the third is a controller. So what is a controller? Controller is something that facilitates view and updates the model. For example, let's understand it with an example. Let's say model is a user model. So we have a class, something like let me show you. Let's say we have a data class, something like a user. Okay, and val id equal to long, val name equal to string. This is our model, and we what we want to do is we want to store this model into our database system. So now this user is our model, right? This activity, someone wants to join. Yes, Avino, please.
Yeah, hi Raju. So we won't be on latest architecture like MVI. We won't be talking on that.
No, MVI we won't be talking because it's a not something that it's a latest. The things is
Mm.
it's a yes, you wanted to something say
No,
something.
no, no. I'm sorry.
Okay, Cool. So the things is it's a not a latest. The things is it's a not sort of a prominent one. And what based on what I have seen is only a subset of our developers use the MVI, because a lot of around a lot of percentage of the people just use a MVVM architecture. So I'm explaining MVC and MVP because again it's a these are the older architecture models. So if you understand them, it would be easier to understand MVVM. As well as even in the interviews, the interviewers focus on they really don't focus specifically on MVC and MVP, but they ask questions around MVC and MVP as well. So
Okay,
MVVM is okay. So that is
got
why we are not going to focus on MVI, model view and intent thing. Cool. Yes, where were we? Yeah, here. So this is our user class. So this is our model. Okay, and this activity is something that users will be seeing. So this is our activity, could be a view. Now, what is the task of the controller is model view and controller. So the model represent data and business logic. It represents business logic as well. The view displays the UI, that is activity, and controller handles user input and update the model and view. For example, in activity, this is view. So if there is a button called if there is a button called add user, right? So when we click on this button, we really need to add the user into database. That means we need to update our model. So who you cannot directly go and talk with the but we directly cannot go and directly add the to the model, because again it would be messy, right? Then view will need to have all sort of these things, and it needs to contain all the code. So what happens is we create a separate class called a controller. So what controller will do is controller will allows the view to update the model. Okay, as you can see here. And so what in MVC what will happen is there will be a view will notify the controller when you click on, for example, when you click on the button, view will notify the controller that hey, user clicks on this button and this is the data. So what controller will do, controller will go and update the model, that is it will add the user data into our database, and then the data will be provided to the view from the model. This is how MVC architecture works. Okay, this is how it works, and you can see view is directly connected with the model. In our case, view is directly connected with the model. So these are the few advantages: clear separations of responsibilities, easier unit testing of the pres no, this is different one, sorry. Modularity and separation of concern. So what is the separation of concern? We are separating out the concerns related to each functionality. For example, view will do only its own task, that is to show these things, and whenever user clicks on adding or removing the data, view will notify the controller. So the task of the controller is to uh, get the data from the view and update the model. Okay, and model will update itself, and then it will provide the data to the view. So there are now this applies that separation of concern. We are separating out the different concern for view, controller, and a model. Support for a multiple views. You can have multiple views, and well established and widely used. So MVC dates back to around 1970. Okay, MVVM dates back to around 1970. So it's a widely used as well. We are not talking just for the mobile applications. MVC is widely used in web development as well. For example, a lot of people use it with the PHP or .NET, those sort of things, ASP.NET, while you build the web applications. So this is how the MVC organize the things. Okay, so architecture pattern is what? It's just how you organize the things. So this is how MVC organize the things. Uh, and there are a few advantages as well. For example, complexity between managing communication between components, and tightly coupled between view and a controller. So view, so tightly, yes, the coupling is important to understand. So what is a coupling? Coupling refers to how your what to say? have your items, or I would say what would be the good one for these things. Have your let's go with the items. I'm not able to find anything. How your items are connected with each other. For example, if you need controller only and only controller, and we cannot substitute controller with other classes, that means the view and controller are highly coupled. That means you have to have provide the controller to view. You cannot substitute it with other classes. Okay, so this is known as a high coupling. If you have a code, a nice code, where view is taking the controller, but you are able to substitute the controller with other classes as well, that means there is a less coupling. And in ideal world, your code should be, there should be a less coupling in your code. It should not depend on certain classes. Uh, if there is no option, then it's fine, but ideally you can write a code that where dependencies should be easily replaceable by other classes, so there should be a less coupling. So this is what known as coupling. Now the second part is MVP. So instead of the difference is, instead of the controller we have presenter, but we have, as you can see, there is a few other differences as well. So MVP represent the model, view, and a presenter. View is here, presenter is here, and model is here. So whenever any action occurs, view will notify the presenter, presenter will update the model. The another important change here is in the MVC, model was giving the data to view, right? So here the presenter act as a middleman, complete middleman. See, view has a no connection with a model. So your activity has a no connection with your database system that is actually storing the data. So what will do, view will tell the presenter that, hey, add or remove a data. View will do it. Now the model gets updated. So what model will do, model will provide the data to presenter, and the presenter will provide the data to the view. In earlier case, model was directly giving the data to view, but in this case model is giving data to presenter, and presenter is giving to view. So this is how MVP architecture works. This will be more clear when we see these things in action using the code. We will write the code as well for MVVM architecture. Okay, so these two are for understanding MVC and MVP. So it is similar to MVC, but introduce the presenter components to handle the communication between view and a model, as you can see on these things. And the presenter acts as an intermediary and updates the view based on the user interaction and data changes in the model. Again, advantage is a clear separations of responsibilities, easier unit testing of the presenter, support easier UI customization, and these are few disadvantages: increased complexity due to introductions of the presenter, and can result in a large number of interface. So interface segregation and those things probably we will see with the solid principles. Cool. So this is how MVP works, MVVM and MVP. This is how this two architecture pattern works. Again, MVP is since a long, just after MVC we had MVP, and now we are going to focus on MVVM. We will write a code for it. We will understand these things in detail. Earlier too, I was a bit quick because I just wanted to give how it works. But in MVVM, we will really understand how these things works and what are the difference. Cool. So now comes the third architecture pattern, that is MVVM. So it stands for a model, view, and a view model. What it does, it separates the UI from the data using a view model. So earlier we had a presenter, now we have a view model. Okay, that's not the only difference. We will see the things. The view model exposes data and commands to view, which in turn binds to the view model to display the data and handle user interaction. Okay, uh, let's understand it with a more detail. So let's say we have a view. This is our view, and this is our model, which you are familiar with. This is our model and this is our view. Now here comes the we have a M, V, Now what we need a VM. That is our view model. This is our view model. Let me make it bigger. Okay, cool. So what is happening? We have a view model, view, and a view model. So let's understand how it works. Uh, uh, Whenever there is any data changes occurs, what will happen is okay, what will occur? What will happen is whenever there is data changes, when you click on it, the views will notify the view model that something happened. Okay, but for example, user click on the delete button, or user clicks on the edit or insert whatever button. Okay, view will notify the view model. View model will act upon it, and view what it will do is view model will update the model. As you can see here, view will notify, sorry, view will notify the view model, and view model will update the model, just like a MVP. Okay, this flow is just like a MVP. Here it starts to get deeper, right? You can see the dotted lines here. Here there is a dotted lines. So what is happening now? Whenever the model gets updated, what will happen is model will expose observables. I'll explain the observables later. But what will happen is model will tell the view model that, hey, something happened, and there is a new data in my database. Okay, what view model do? View model will grab the data, and view model will let me see if I can have a dotted lines. Yep, view model will notify the views. Okay, so this is how it works. So how it difference in a MVVM, this was a view was notifying the presenter, and presenter was updating the data. But what is happening is view had, for example, model was holding the presenter, and presenter was holding the views. That is, for example, let's say this is class presenter. So what is happening? The presenter was holding the instance of a view, for example, something as a dependency. Well, view. Okay, this is how it could look like. Presenter was holding the view as a dependency, and then it was accordingly, for example, function update user. So what it could do is it could view dot update user. So presenter had an instance of the view. Now in this case, MVVM, what is happening is the left, for example, the right layer, the as you go in the right side of a layer has no idea about the left side of a layer. Okay, for example, model won't have any idea what the view model is. It doesn't care what the hell it does. Okay, so in view model, what will happen is right side of the model won't have any idea about the left side of domain. For example, model won't be knowing what is view model, or even how, whether there is view model or at all. It doesn't care. What it says, hey, this is, I have some database changes, and this is the new data that I have. If you are interested, keep it. If there is a view model that is interested to have this data, they will get notified. Okay, now again, from the left to right, view model will have no idea about this left layer, that is a view. View model won't be knowing is there any activity, any fragment, any composable. It doesn't care. It simply says that I got some data from the model and I have it. If anyone is interested, please have the data and update yourself accordingly. Okay, I don't care what you do with the data. Okay, so this is how the things works. Earlier, these things had to maintain an instance of this left layer. In the case of a model, it has to maintain this one. Okay, but in MVVM, what is happening? The model is notifying the view model using the observables. I'll explain the observable, and then view model is notifying the views. Basically, whoever is watching it, whether it's a view or whatever. So this is how it simply looks like. We have a view, we have a view model, and we have a model. So if we try to write these things in form of a code, how it will looks, let's try to write it, so we will be better understand it. Okay, So now we have a user. Let's create a data class called a user, and let's create a class called a user database. Okay, it's not an actual database, but let's just try to emulate that. Okay, this function does something like this: user database and function insert user, and here we will insert some user. Mm, for example, insert user, we are just emulating. Okay, we are not doing any actual operations, and we will have a function called let's say get user. So it will just return a user class that is let's say id equal to 1 and the name would be abc, whatever. Okay, it will return this user. So we have this class called database. This is it will allows you to get user as well as a insert user. Okay, this is part of a model. This is the whole part of a model. This is our database and this is our actual data. Now between view and a model, we have a view model. So this is main activity is our view. This is our model. Okay, let's call it user model. That would be good one. Cool. This is main activity. So between these two what sits, there is a view model. So let's go and create a new class called a view model. So let's call it a user view model. And let's create a class something like this. This is our user view model. So what will happen is this left layer will have an idea about the right layer, but right layer won't have an idea about the left layer. That means view model will know about the model. Okay, but model will know about won't know about the view model. So in the view model, view, as we said, view model will have an idea about the model. So that means we in the let's call it user database. Yes, so view model has an idea about the database, right? Okay, this is the class that manages the user, this one, this user database. So view model has an idea about the model, but as you can say inside the model has no idea about the left layer, that is a view model. Okay, now same goes for the views. View will have an idea that okay, what is a view model, but view model won't know about view. So let's say in the main activity, let's just create well user view models, and we will just assign user view model something like this. What we need to pass, we need to pass a user database as well. Cool. So this is the pretty very simple things. We will move advanced, but this is the most basic concept. Okay, there is a view, there is a model, and there is a view model. So this is our view, this is a model, that is database, and that is a view model. Okay, till this point it is clear, right, for everyone? Any question around it? Uh, any questions or anything? Okay, cool. It seems +1. So okay, this is how it looks. Now we will proceed ahead. Uh, so now what is happening? This is view model, this is view model, and this is our main activity. So it will have access to the view model. And now see, view knows about the view model. Our view knows about the view model, but view model does not know anything about the view. That is a main activity. This is the pretty simple concept. Now we will move advance on this view model part. So what will happen is if we have to just create a simple class, then it was present in the presenter as well, right? If it was a simple class, then what is the use of this why use of this view model, right? If, even in a simple Kotlin or Java file, you can create a simple class and you can just use it. What is the benefit that MVVM brings here? The benefits MVVM brings here is we have a special, this view model is a special class of a class that is known as a view model. So whenever you create a view model, what you will do, you will create a class, you will provide all the dependencies, and then you will extend the view model. You will extend via the view model. So we will understand what this class does. Okay, so it is, as you can see, it is a public abstract class of view model. So view model is a class that is responsible for preparing and managing the data for an activity or a fragment. It also handles the communication of the activity fragment with the rest of the application, that is calling the business logic classes. Okay, so what is the duty of the view model? The specifically it has a two duties. The one is, see, let's take this an example. When we were rotating the device, this value were getting lost, right? And we had to implement the on save instance state and on restore instance state to store the value. Now this was a problematic. Suppose you have a 100 variable. So would you assign the 100 variable values to all these variables on saved instance and on restore instance state? This is not ideal, right? So what we want from the view, this view model, is the first things is we want it to store a values which we do not lose even on the configuration change. Even if the configuration change happen, let's say we rotate the device, or we change the themes, we want this view model to store the values even in case of the configuration changes. That is one thing. So we don't have to deal with these things, and we can just store the values in the view model and they will be retained even after the configuration changes. That is one thing. Second thing is we want this view model to communicate with the next part of the application, that is a view, that is a model part, this one. So we are assigning a model, that is database here, right? So view model perform basically two duties. First thing is it maintains the data for activities, that is our views. And the second thing is it allows the communication with the later part of the application, that is this one. So what you will do, you will create a view class. View model provides all the dependencies that you need, and then you will extend this abstract base class view model. Okay, so how it retains the data, that is a separate story. We need to dive deep, and basically we need to go through the AOSP code, because I went through these things. So there are two classes called active. For those who knows the context, who are experienced developers, they may know, right? Interviewer often ask how view model survives the configuration changes. So the how is a different story altogether, but basically it has to deal with the activity caller thread and activity record. These two classes are in the AOSP code, that is Android open source project code base. So I'm just mentioning it, you can just go and have a look at as well. Cool. So this is the definite task of the view model, and this is what view model will does. Now we define these things: model, view model, and view. This is something we define. Okay. Uh, this is done. This is main activity. This is our view model, and this is our model. Okay, this is done. Now we will add some more things. We will make it more fancy. Okay, so now suppose let's say this is a database, and let's say if you get the user, for example, let's create this function here. Okay, let's create this function here in the view model. Let's just create a get user function, and what we will do is we will just return user database dot get user. We just did these things, right? We are just calling it. We are just calling it. Now what will happen is what will happen is if you have a single view model, and let's say you want to apply some business logic. So a lot of developers confuse when they heard the word business logic. So what is a business logic? Business logic is nothing. It simply means how you want to represent your data, what logics you want to apply before representing this data. For example, if you get the user, okay, you get the user, and this is your user that you are storing, and you have another class. For example, you have a data class called mini user, something like this. I don't want to make it complex, which just has a which just has a single property called a well name, and it's a string. Okay, you have this data class. So what you want in the database, you want to store the user, but in the UI, you want to represent mini user. So what you will do, you will map this user. You will, sorry, dot, this is what, this is user. So you will map these users to mini user. Okay, so what we will do, let's create a function here, fun, convert user to mini user. So what it will does is it will take user as a parameter and it will return mini user, and for the name we will just pass user data name. Okay, it will convert user to mini user. Convert user to mini user. What's happening? Yes, convert user to mini user. So now we will, what we will do is we will first get the user, let's say well user, and then what we will return, we will return convert user to mini user, and then we will return a user. So this is our basically business logic. We don't, in the DB we want to store and retrieve as a user, but we want to show, we want to give this mini user to our view, that is this view. Okay, now these functions will return a mini user. Now let's say if you have a multiple view model, this is a user view model, this is user view model, and you have another view model, let's call it admin view model, something like this. You have admin view model. Again, you will just extend the view model, and you will just get this one, something like this, sorry, and then you will have something like get user. Okay, you have these things called a get user. So what is happening is in the user view model and in the admin UL, you are getting the user, but you are, sorry, you are getting the users, and you are repeating this operation, right? You are repeating this operation, converting to mini user. So the function is same, you want to get user as a mini user, but you are repeating these operations. Okay, you are, so this business logic is something we can move somewhere else instead of defining it in a view model. This business logic is something we can move it somewhere else, right? So here comes the concept of a, let me mark it this one. Yes, here comes the concept of a repository. So what is repository? Repository act as an intermediate between view model and a model. So let's, view model should not care about from where the data is coming, whether the data is coming from the network, or whether the data is coming from the local database, or whether is data is something randomly generated. View model should not care about it, and it should not even know about it. Okay, so now between the view model and the repo, what we will do is we will put the repository between view model and a model. So now this is how it works. Now we will move the model here, and we will move these things something like here. Okay, so this is how it looks. View model will talk to the repo, and repo will talk to the model. So what we will do is we will create another class called let's call it a user repository. This is a regular class. So here repo will have access to model, right? So in the repo, let's define it something like this, and let's define this get user function. What it will does is it will convert to mini user. Now we can move it to the repo itself, something like this. Okay, so now view model will have access to the repo. So in the view model, instead of database, we will have user repository, and the user repository we will just simply call this one, right? User repository dot get user. So we can just simply return it, and we can just reuse this business logic in the repository. So same applies to other view model. Even if you have multiple view model, you can just use the same repository to get the same data. Okay, cool. So this is how it works. This is our view. These two are a view model, and this is our repo. So in the main activity, we have to pass the user repository, and here user database. Fine. Cool. In the production code, you don't do this thing. Basically, you use dependency management, but that is something we will see in upcoming sessions. Okay, so to put it simply, this is how it works. So we have four most important things in MVVM: a view model, repository, and a model. So these four are the base of the view model. So if you want to extend it, which I'll explain using the use cases and what are the use cases, when to use it, that is something we will see. But this is the base of the MVVM architecture. Okay, view model, repository, and model. Cool. Now it's 10 p.m. So we will take a quick break. Before we go for a quick break, any questions around this architecture model, or is it clear for everyone? I'm suspecting some question, and that is awesome. Yes, Saurabh, please.
सर मेरा मतलब एक क्वेश्चन यही था कि जैसे कि जो
Sure.
मॉडल है अब यहाँ पर रिपॉजिटरी क्लियर आ चुकी है तो इसका मतलब कि जो व्यू मॉडल उसको ये नहीं पता कि डेटा कहाँ से आ रहा है तो उसको मतलब डेटा से
Right.
मतलब जैसे आपने कहा था और
Right.
जैसे व्यू है व्यू को भी
Hmm.
मतलब एक तरह से पता कि डेटा कहाँ से आ रहा है बस उसको ये पता कि व्यू मॉडल एक तरह से उसके लिए डेटा ला रहा है तो यानी कि
Right. Right.
हर मतलब कि व्यू मॉडल जितने भी लेयर्स हैं सबके लिए ये चीजें एब्स्ट्रैक्ट है काइंड ऑफ
हाँ, सॉर्ट ऑफ एब्स्ट्रैक्ट, उसको पता नहीं है कि कहाँ से क्या आ रहा है, उसको जस्ट ये पता है कि बस आ रहा है मेरे पास।
ओके
ठीक है, whether it's coming from the network or local database or from randomly generated, it doesn't matter. उसके पास डेटा आ रहा है तो उसको पता है कि भाई मेरे पास ये डेटा है, अपडेटेड डेटा है, जिसको चाहिए वो रखो, एंड अदरवाइज नहीं चाहिए वो रहने दो।
ओके ओके
सर
ठीक है
इसी को
भैया
लूज कपलिंग बोलते हैं।
सॉरी।
इसी को
हाँ,
लूज कपलिंग बोलते हैं।
loose coupling is again something. Loose coupling means your components. Yes, I was telling the word item, it should be component. So loose coupling simply means your components are not tightly coupled. Tightly coupled means you cannot replace it. Okay, you cannot replace it. For example, in the view model, if you use just a concrete implementation of the repository, then it would be difficult to replace it. But if you use a interface based implementation, that is, you define your interface for the repository, I'll explain it. You define an interface of the repository, and then you implement this repository for this interface, then it can becomes a loose coupling. Loose coupling means it's not tightly dependent on some particular classes.
ओके,
Okay.
मतलब ये लूज कपलिंग नहीं थी जो सौरभ ने अभी एग्जांपल दे रहा था कि हमें कि व्यू मॉडल को व्यू का नहीं पता, ये लूज कपलिंग में नहीं आता।
Hello.
हेलो।
Yes. So yes. Okay. So your question is ki view model does not know about these things. So yes, that is something you can say as a sort of abstraction. We are abstracting away the actual implementation, and we are just giving them the data. So sort of abstraction. We are abstracting away the details.
ओके
Okay.
ओके सर। यस।
Cool. Any questions around MVVM architecture? This is the most basics, and this is what you will see in most of the code base. You won't find use case much in the production level code base. There might be, but relatively it's a small. So this is what you will see in a production level MVVM architecture: view model, a repo, and a model. Cool. Any questions? Sanskriti, your mic is on. Do you have any question? Hello. It seems yes. Cool. Then let's do one thing. Let's take a quick break for 7 minutes, and then we will be back by 10 p.m. and then we will continue our view model. I'll explain a bit of the observables, and then we will understand the use case as well. Okay. Cool. Let's come back sharply at 10 p.m. Okay, cool. So is everyone back? Awesome. Let's wait for just 2 minutes and we'll start then. Okay. Yep. Let's not waste more time on it, and let's continue the sessions. Okay. So this is what we were saying. This was our view. This was our view model, and this was our repo, and this is the model, and this is how. What is this? No, we don't want to update. This is how it basically works, and now and the one things you will notice here is this dotted lines, right? So what it says that view model notifies the views and model notifies the view model. So what does it actually means? What does it means to notify the things? So to notify other components, we have a concept of the observables. So before we understand the observable, let's see what it means. Okay, let's see what it means. So let's say let's have a class. This is our repository class, this repository, and this is our view model class, right? So what will happen is in our main activity, or I should explain probably if I use a view model. Yes, one sec. So yes, how to, and one important thing is you cannot directly get an instance of the view model, something like this. For example, let's say let's in the main activity, let's have a button, let's have some code that can do something for us, right? So in the main activity, let's add a button. Let's quickly add a button. Instead of the text, we will have a button, and let's set the type equal to insert user. This will, what it will do is it will insert a user. Okay, this will insert a user. Let's give it a ID. We want to have two button, one is for inserting the user and second for the getting the user. So let's call it insert user. Okay, insert user. Now we will create another button below it, and the ID would be get user. So we will write get user constraint, start and top is fine. So sorry, start and end is fine. Top to bottom would be top to bottom would be this one ID, and insert user. We want to keep it something like this, right? Insert user and get user. So we have created two buttons. Now let's write the code in the main activity. So we will use a private let init where insert user, that is of type button, sorry, button, and we will use a get user, that is type of the button as well. We'll find them. Insert user equal to find view by id, r.id dot insert user. Similarly for the get user, we will write the r.id dot get user. Okay, and let's have a click listeners as well. Insert user dot set on click listener, and get user equal dot share on click listener. Cool. So now we need to store them, right? So we are not maintaining an actual database. We are not maintaining an actual database. So what we will do is in the repository, let's create a list. Let's maintain a list here in the repository. Let's say, well, users, and the type would be it's a mutable list of type is a user. Where is user? Something like this. Okay, so we have a list of the users called a mutable list. Because we don't have a database, we will just simply use this list to retrieve the users. Okay, so in the user repository, we will write a functions called insert user, and we will expect the user here. And what we will do is we will just insert into the users. So users dot add, and we will, whenever the user click on this button insert user, we will go to, where is the yes, this one here. We will similarly create a insert user function. I'll show you. Insert user, and we will call the repository dot insert user, something like this. We need to pass a user here. So we will just create it does not represent anything, right? We will just create a user. Let's create a new user here in the database, sorry, in the VM. So let's call it a user. ID would be int ID would be, let's say, 1, and name would be Rajesh. We are just creating it, and we are just passing it to the repository. So what we want is, when we click on this insert user button, what should happen is this function should get executed, right? So let's try to do it. So from the view model, we are calling the repository function, and repository function will just add it to the users these things, right? Users list. Okay, now what we will do is we will go, and here we will just call the, what we will call the user view model dot insert user. Okay, this is something we want to do. We will call the user view model dot insert user. We are getting the view model here. Okay, we are creating a view model object, passing the repository and passing the database. Okay, it's making sense for everyone, right? What I'm doing is basically, I believe it's a simple. Cool. So let's try to, we will implement the get user later. So let's try and see what happens if we are able to run it or not. Cool. So now if I click on the insert user, uh, what happened? Is there anything happened? Any user was inserted at all or not? Okay. So here let's do one thing. In the get user, let's call the view model dot a get user. So user view model dot get user, something like this. So we will just call this method. Inside this method, what we will do is we will return the user. So let's just try to log them out. Okay, so we will write just let me copy the logging utility, that is this one, and this user is a list of the users, right? So because it's a, what it is, it's a list. So we will return so this user is a list, so we will just get user. What's happening? Yes, so what's happening, man? Okay, just give me a sec. Yes, let's keep it here. So in the insertion users, we can probably write this code here, and here we will again write user dot, sorry, user database dot insert user, and we'll just pass the user equal to user. Cool. So now what we will do is we have the users in at the database level. Okay, this is, let's say, our database. So in the return, what we will do is we will return a users. We will return a user, something like this. It's a list of the users. So these functions will return a user. And now from the repository, again, this will return let's say user. Sorry, what's happening, man? Let's just return this one. Let's just return users. Let's just return user. So it would be a list of the users, something like this. We are just returning this list of the users here. Okay, so now in the view model, again we get the users as a list of the user, right? List of the user. So we will iterate over this list user dot of uh, for each, and then we will debug them out. We will just debug the name. Okay, so we will write it dot name. This is something we want to print it. So we'll write something like a name, and we'll write this one. Let's run these things. There is an error. So yes, this function does not return anything. Let's run these things. What happens? Oh, this function does not return anything at all. Let's run it again and again and again. Okay, so let's open the logcat. So what we are doing in the view model, this function is supposed to insert a user, and this function is supposed to get the user and log them. So let's say insert user, click, 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 click. Okay, I think it's a here. Yes. Let's click on the get user. So you can see we are able to get the users, right? We are able to get the users. There are two users, this name equal to Rajesh, as you can see. Okay, for example, let's say if we use a randomly generated id, random dot next int, sorry, next long, and let's say we print out the whole user dollar it. Now let's see what happens. Okay, we created these things, insert user. Let's say we have inserted some users, right? And if we click on the get users, as you can see, the ID is randomly generated and we are getting the list of the users. Okay, so this is coming from this user repository, and the repository, sorry, this is coming from the database, right? Because database, we are storing the users. So this is how these things works. This is how these things works. View model, these repositories and all those things. And view model is responsible for maintaining the data. Okay, now let's see how to one sec. View model, why, what's happening? Extend the view model, extending it. Uh, one sec. Android X. Uh, give me a sec. View model. I think it's not working. This things is properly not working. I think due to the conflicts of this one, but yes, we have created a class. It is a view. I think it's coming from which dependency? Lifecycle view model 2.6.1. So do we have it? Let me go and check it out in the Gradle script. Lifecycle. I think we don't have it, right? View model. So maybe it is coming from previous one. but it should not be something like this. So the things with a view model is, I think this is not properly working, because the things with the view model is you should not be initialize the view model yourself, something like this. Okay, here we are using view model, but it you should not be, something is wrong. I'll figure it out. So you should not be able to initialize the view model yourself, something like this. Rather, you should use a view model provider dot get, and then you can provide the type of the view model. So import the class. This is how basically you should be able to do something like this. So you can use a private let init where user view model, and then you can use something like this, user view model equal to do something like this. And as your view model is taking some dependencies, you need to use a view model factory to pass the data as well. It's not working, but this is how it works. Okay, but okay, our concern for now is what to say, where did it went? Yes, I need to figure out there is some dependency issue thing, otherwise it should not allows us to directly create a view model, something like this. It does not even allow you. And as you can see in this view models, I am not able to access the view model scope as well, which should be present. Okay, but so I think it's not working. But anyway, let's focus on the main part. View model we'll see. So this is done, and now yes, this is the observable things. So what is the observable? So in the repository, yes, in the repository, or where do we have created variables? So model, this is a list. So for example, you have if someone has question, yes, Sanskruti.
So the view
Hello.
model. Hello,
Yes, yes,
can you hear me?
yes, please.
Yeah. So the repository should only contain the functions or logic which are multiply used in other view models, right? Or something.
Uh, yes, yes, please
Like
continue. Then
because
I'll answer.
within a view model we are also defining the logic.
Okay, right. So
So the
the no.
repository, so for the repetitive, the
Mhm,
code shouldn't be repetitive. For that purpose, we using repository for
mhm.
those code which we are using multiple times and multiple view models. That's why we are using repository.
No, so the actually answer is no. Why I have explained this way, key, if you have multiple view model and if you want to reuse these things, go for the repository, because to simplify the things, it's not that only if you are using a logic for a multiple times, then go for the repository. You should always go for the repository. Reason being, your view model should only be dealing with the data that it is getting. No, it should not deal with from where it is getting the data, whether it's from the network, local DB, or however. So this is the reason you should always go for the repository, even if you are reusing the business logic or not. Okay.
So
Yes.
just to get the data, that's why we're using repository.
Yes, just to get the data and to apply some business logic, if any you have, just to
Okay.
get the data with, for example, let me tell you some complex example, that way it will be more clear. For example, if you are using a infinite low paging, okay, if you are using a infinite paging, that means you automatically make the network request for the next page to the network. So this is how your flow looks like. For example, your first step is a make a network request. Okay, second step is save data into local DB, and third step is give data to upper layer. Okay, So what is happening? Three different things is happening. You are making the network request, you are saving the data, whatever the data you are retrieving from the network request, you are saving into the local DB, and then you are giving it to the upper layer. So view model should not perform all these things. View model should only be concerned with holding the data. Okay, consider view model as a holder. It should only be responsible for holding the data. So you cannot move all these things to the view model. This is why this should go into the repo. Okay.
Okay, got it.
Cool. So have a repo along with the view model. Okay, so this is how it looks like. This is how insert user works, and this is how it looks like. Now let's talk bit on this observables. So if you have a regular variables, I'll explain the observable in more details in tomorrow's session. That is, we will cover the state flow as well. So state flow is a type of observable. So we will see this tomorrow. But observable is simply if you have a regular variable, something like this. If you have a class, my class, something like, if you have your class, and let's say this class has a counter property equal to 0, and you have this function called update counter, and what you will do is you will do counter plus plus. Okay, and then you have another class here, let's call it main function, and here what you are doing is you are holding the my class equal to something like my class, and then what you are doing is you are printing a counter, then you are updating the counter. Let's call the my class dot update counter, and then you println. This won't make much sense here, but let me try to explain it. Okay, so what is happening is you have a variable and you have a update function. So what will happen is you have an instance of the class, then you are accessing the variable. Try to understand it this way. You are accessing the variable, then you are, what you are doing is you are updating the variable. Okay, if you update the variable, if you are update the variables, whoever is reading this variable, for example, earlier I was reading this variable, right? Earlier I was reading this variable. So whenever we update the variable, it won't automatically go and tell the observer that, hey, my value is updated. If you want to print the new value, you need to reread it again, right? Something like this. You need to basically reread this variable. So this is a normal variable and standard behavior. That is fine. Now what happens is there is a concept called observables. So what are observables? Observables are the variables or objects that tells, whenever the value gets updated, they tell their observer that, hey, my value is get updated, please use this new value. So what will happen in this case, if you make a counter as an observable variable, uh, probably we will see this tomorrow. So let's say, for example, you are using a state flow. State flow is a type of observable. Okay, so if you use a state flow and then you update the value of this state flow, what will happen? Whenever you are reading the value, you don't need to go again and reread the value for an updated value. What will happen is wherever you are reading the value, the state flow will go and tell this line that, hey, my value is updated, now please keep the new value. Okay, state flow or observable will go and tell whoever is observing this observable that my value is now updated, please keep this new value and do whatever you want. So this is the basic fundamental concepts of the observable. Observable allows you to hold a value at a time, and whenever the value gets updated, whether it's increment, decrement, deletion, whatever. So whenever the value gets updated, whoever is observing this variable, special variables, uh, they will the state flow will go and tell that, okay, this is the new value. They are known as reactive variables as well, and this concept is known as a reactive programming. Okay, so what is happening here? The variable is reacting to the changes. Whenever there is any change occurs, variable is reacting to the changes. So this part of a programming is getting a very popular, and this is known as a reactive programming. It's called a reactive programming instead of the traditional programming where we had to go and reread the value to get the updated value. Reactive programming is becoming popular day by days, and we will see these things in details tomorrow. I'll explain the state flow because state flow is a part of a Kotlin coroutines. Okay, and coroutines is again coroutines, all of you know, right? At least the basics. We will see these things in detail tomorrow. So state flow is a part of a coroutines, and state flow is a type of a observable. Another type of the observable we have is from the live data, that is from a Google, which people used to use this live data when we did not have the state flow. But now as we have state flow, it doesn't make much sense to use the live data. Uh, there are a legit use case. For example, if you are writing the plain Java code, you are not moved to the Kotlin, or if you need a situation, if you are in situations where there is a no initial value, in this case you can go for the live data, but it doesn't make sense for a Kotlin project at least. Okay, so this is the live data. Live data is a type of observable. Tomorrow I'll show you these things with a live demo, how it actually works. Okay, so don't worry on that part. I'll explain these things with a state flow, but live data does work the similar way. Okay, I'll show you one regular variable and I'll show you one reactive variable, that is state flow. So what is happening in our uh, diagram? The repository is exposing the repository may or may not expose the observables, but view model usually expose the observables. So what view model will do is, instead of having a regular where is view model, instead of having a regular variable something like this, well user, instead of having a variable like this, what view model will does is view model will provide some observable variables. That means whenever a user calls the insert functions, users will insert it. And if we are reading this user from the database, as the user is inserted, new value will provided here, and this user, this activity, that is this activity will be observing this user. Okay, the activity will be observing this user. So without activity doing anything explicitly, activity will get a new value. Okay, because the state flow will go and tell the activity that, hey, I have a new value for this user, just use it. So without explicitly reading the value, activity will get the new value. So this is the concept of a view model exposing the observables. So we will understand the state flow tomorrow. And as we these things is a pretty must have in a view model, so we will always use it later as well. So this is the concept of the observable, and what remains? Use cases, right? Yes, this is model layer, UI layer, MVVM layers, yeah, domain layer. So that contains a use case. So now this till this point, it is clear what is MVVM architecture looks like. So now let's extend it a bit further. Okay, let's extend it a bit further, something like this. Let's say something like this. Yeah, so what you want is your from where you are fetching the data is in your repository. From where you are fetching your data is in your repository now, and you are getting the data in a view model. Now it's not impossible, that it's not a strict rule that you cannot apply any business logics in the view model. You can apply. Okay, and this is especially useful when you are doing the duplication. For example, let's say you are getting the user. Okay, I'll explain these things. Okay, you are getting the list of the users here. So what you want to do is, sorry, insertion or getting the users, right? Yes, getting the users will give you a list of the users. Now what you want to do you are retrieving this from the database, that is repository knows, your view model does not know, right? But what if you, whatever the users you are getting, that you want to convert to the mini user, so you want to map it to e dot convert to mini users, and we will just pass something like this. So whatever the users that you are getting from the, from where it's not a view model's concern, from the DB local, wherever, view model only wants to do what it wants to do is it wants to map to, or basically it converts to the mini user. And let's say both of our view model wants to do it, admin view model and both of our view model wants to do these things. Okay, both of our view model wants to do these things. Now this is a duplication, right? We are mapping the users again here. Both of view models wants to do the things. So we have this view model 1 and we have this view model 2. What they are doing is both of them are reading from the repo. This is user view model, this is admin view model, and repo is giving them a value. As you can see, repo is giving them a value, the repo is giving them value, and then view model is converting to uh, this mini user. Okay, now this is a duplicacy. So what we can do is we can add one extra layer here. Okay, for example, let's have something like this. And yes, to avoid this duplicacy, what we can have is we can add one extra layer known as a use case. Okay, something like this. They are known as a use case. So what will happen is whatever the common functionality is for this view model, we will extract it out. Okay, so what is the common functionality? We want to get the users and then we want to convert it. So for that, we will create a use case. So let's call it a user use case. Let's call it, let's create a new file, a class, and let's call it a user use case. This use case falls into this domain layer, and that is optional. Where it is, yes, this UI layer is this one, view and a view model. This data layer is your repository and a model, and this domain layer, that is optional, that is your use case. So we will extract out the functionality and we will create a function here called a get user. So what this function will do, these functions will retrieve the data from the repo. Basically, instead of doing these things, we will make this class to retrieve the data from and within the repo, and both of this view model will now to talk to this use case. Okay, so instead of view models talking to the repo directly, they will talk to this use case. Use case is nothing but a plain Java class. Okay, Kotlin or Java class. So we will write something like this. We will have it something like this, and we will, after mapping, we will just return them. Okay, after mapping, we will just return them something like this. So now it will return a list of the mini users. So we can save this operation in the view models here, right? So now view model needs to depend on what use case. So it will depends on a user use case. Okay, and I'll comment it out for now. So it will do define something like this. Okay, so now it will return a list of the users. Okay, so and same for the other view model, that is not this one, that is admin view model. So it needs to depends on the use case, and based on the use case it can retrieve the data. Now it does not need to map it, right? Because it is actually getting the list of the mini users. So this was the common functionality that we have extracted out into the use cases. So this is what people sometimes use, but it's not a quite popular. Okay, some people use the use cases, but it's not a quite popular that okay everyone use it. The basic MVVM is what I have explained: view model, repo, and a model. View model communicates with the repo. But if you have this sort of a functionality, you can prefer to go with the use case as well. Okay, and even the Android documentation suggests that this is an optional layer. So UI layer is, we have seen, data layer is we have seen, and the domain layer. So the domain layer is an optional layer that sits between UI and data. The domain layer is responsible for encapsulating complex business logic. We are encapsulating complex business logic to provide a simple return type. That is, now VM doesn't need to worry about this business logic. That is something will be provided by the use case. Okay, or simple business logic that is reused by multiple view model. As you can see, this is reused by the multiple VM, right? So that is provided via the use case. This layer is optional because not all apps will have this requirement. So you should use it only when needed, for example, to handle complexity. So the classes in this layer are commonly called use case or interactors. So if you find a class that is suffixed with a use case, or you might find it as interactors as well, for example, user interactor. So it's just a convention, not a hard rule, but it's just a convention that classes in this layer is known as a use case or interactors, and each use case should have responsibility over a single functionality. Okay, for example, if you are inserting a notes into the database, so to add note into the database, you should have a use case. This use case should not contain a functionality of deleting the note. Okay, this should be delegated to other use case. So a single use case should contain a single functionality. So that's the things about the use case which you might heard from the few developers who use them. Personally, I don't use the use case until and unless necessary. I just go with the plain MVVM. But a lot of I would say subset of people use case as well. Cool. That's I think that was all for the MVVM architecture. This is how it works, and this is how it works diagrammatically. This is how it works in a code. What is the UI? What is the view model? And all these things. View model is probably I'll explain more on the view models later, including this what to say, observables. But this is all in all. This is how user use case. I need to pass it. Right, in the repo, what I need to pass a database. Yep. User use case, and then blah blah blah. Okay. Okay, so this is how basically the MVVM view model works. Cool. Then I think we are good for today, and now if I'm open to question, if anyone has any question, feel free to do so. Yes, Tasha, please.
Rajesh, can we discuss the clean architecture a little bit?
Yep. So clean architecture is sort of okay. So what is a clean architecture? Yes, that's a nice question. So you might heard this word clean architecture. Someone will say clean MVVM architecture. Clean. Someone will say clean plus MVVM architecture. So what does it simply means according to my understandings and based on the interaction I had with developers? Clean architecture simply means you use the principles that makes your architecture clean. Okay, so for example, let's say you you use the first things would be, let's say this is your MVVM architecture. First things would be to use a proper packaging structure. For example, if I do something like this, now it's a messy, right? Tomorrow if I want to have a look at it, then let's say tomorrow I will create a 5 class, then it would be messy, right? So what I can do, I can create a package something like this, and this was for week 2 day 1. Okay, and what I'll do, I'll move all the classes into day 1. So now even if I tomorrow I write a code, I will create another package called, for example, day 2. Okay, something like this. So now where it is, new package called a day 2. Oh, since it's already exist. Where it is, man. So inside the week 2, in the source main Java, yep. So this is day 1, this is day 2. So now I'm easily able to identify that, okay, this code is something I wrote yesterday, right? So the first things is you use a proper structures that would be easily identify the things. The The second thing is you make your classes testable. Okay, so for example, what will happen is instead of passing, for example, you have this user repository class. Okay, you have this user repository class. So now let's say you have another repository and it is known as a admin repository. This is admin repository. This is your admin repository, but admin is anyway and user, right? Admin is anyway and user. So what you want to do in the view model or in the use case, you don't want to deal with the concrete class. Okay, what you want is you want either of the repo, that is admin repository or user repository. So what you will do is you will create an interface and let's create an interface. Let's call it a user repository. It's an interface, and now both of these things, user repository, it will implement the interface user repository, and let's give it a name IMPL, that is implementation. Oh my god, where is our user repository? Oh, this one. One second. User repository, override it, and we have this user repository. So what will happen is this user repo IMPL, where it is? What's happening, man? I think yes, I got the file user repository IMPL. Let me just rename it something like this. Yes. So I have created an interface called a user repository. So this user repository implementation will extend the user repository, and even the admin repository will, sorry, implement the user repository. Okay. So now what you will do, your use case will depends on user repository, that is an interface. Okay, it's not a concrete implementation. Okay, it's not a concrete implementation. So now your code is more testable, because if you want to test this out, you don't need either of this actual implementation, whether this class or this class. Okay, for your testing you can simply create a class that just implement this interface and provides a dummy data for all the methods. So now it becomes a more testable, right? So this is another concept. Testing, packaging structure, more readability. For example, you define your variables instead of if you define this variable called, let's say, val counter, okay, equal to integer type, something like this. If you define something like this, so now this counter represent what? Okay, but if you define it something like a user counter, it clearly represent that it represent the counts of the user, right? So now this is a more readable. So instead of just having a counter, you can have user counter, which is more readable. So all these sort of are the things that makes your MVVM a clean. Clean means just by looking at it, you understand what these things is doing. Okay, all these things, all the steps, all the little principles that make it clean, when you combine them with MVVM, this is known as a clean MVVM architecture. Okay, make sense? Cool. So you can just go like you can just uh, uh, these are a few things that makes MVVM architecture a clean architecture. More readability, more testability, more maintainability, those sort of principles. Yes, coming to the next question, that is Dhruv. Yes, please.
सर ये अभी आप यू आर मेकिंग इंटरफेस फॉर द रिपोजिटरीज, उसका फायदा क्या होता है सर? एक बार समझाना, जरा दोबारा समझाना।
ठीक है, ठीक है,
यूज
ओके।
केस में कॉल कर रहे थे ना, अगर वैसे भी तो कर सकते थे।
ठीक है, मैं समझाता हूँ, उसको एक्सप्लेन करता हूँ थोड़ा। लेट मी डू वन थिंग, लेट मी जस्ट हैव इट, फिर आई विल एक्सप्लेन दिस थिंग्स। यूजर रेपो interface is this. One sec. I don't have a get user, right? So I'll just define a function get user, and it will return a list of the user. Okay, sorted. Okay, so abhi what you are asking कि इसका benefits क्या है? Yes, right. So this is basically it's not a Android or Kotlin things, it's a general programming concepts कि हम क्या use कर सकते हैं कि instead of providing the actual implementation, we provide the interface. For example, this is our user repository, and similarly we have another things called a admin repository. Okay, दो repository हमारे पास है, user repository and admin repository, and अपने पास एक class called a use case. So let's call it a user use case. Okay, so now what you want is both of this admin and the user, both of these are a user, right? So what you want this user use case, you want this to take either of this repository. आपको ये चाहिए कि ये class ये दोनों में से कोई भी repository accept करे. Okay, so how can we do it? We can create an interface, something like this, and we can call it user repository. We can create an interface, and now what we will do is both of this is basically programming concepts. We are using inheritance, sorry, implementation, right? So this user, let's call it a user repository IMPL, that is a implementation, and this admin repository IMPL, that is implementation. So क्या होगा अभी कि now अगर हमें ये दोनों, let's say this is not in the case, तो अगर हम चाहते हैं कि यूजर यूज केस में ये दोनों में से कोई भी आए तो चलेगा, तो वी नीड टू डिपेंडेंसी, एक इसकी और एक इसकी, राइट? सो इन द यूज केस, वेयर इज यूज केस, you need a two dependency, that is user repo IMPL and admin repo IMPL. I'll just rename it, one sec. Admin repo IMPL, there is a problem, but that is fine. I'll explain later. ठीक है, तो you need two dependency. अभी हमें क्या करना है, दो नहीं देनी है, हमें एक ही देनी है. तो what we will do, we will create a common interface. We will create a common interface which will contains the method that needs to be implemented by both of these things, but implementation could be differ. For example, let's say ये get user हम करते हैं, ठीक है, यहाँ पर get हम user करते हैं, तो यूजर repositories में get user में हम क्या करेंगे, we will return all the users, but admin repositories में हम क्या कर सकते हैं, if you want to implement it, admin में इसमें हम क्या कर सकते हैं कि we can, one sec, in the repo database में से हम users लेके हम यहाँ पर ये कर सकते हैं कि only return those users that's role is admin. So what we can do, we can filter out the users where it dot role equal admin. ठीक है, तो ये रिपोजिटरी भी रिटर्न्स तो यूज लिस्ट ऑफ द यूजर्स ही करेगी, बट ये सब यूजर्स रिटर्न नहीं करेगी, ये ओनली उतने ही यूजर रिटर्न करेगी जो एडमिन है, और ये रिपोजिटरी सारे ये रिपोजिटरी सारे यूजर्स को रिटर्न करेगी. ठीक है, तो सी द मेथड सिग्नेचर इज सेम, द नेम एंड रिटर्न टाइप इज द सेम, बट द एक्चुअल वैल्यूज इज डिफरेंट. ठीक है, ये एक्चुअल इम्प्लीमेंटेशन इज डिफरेंट. So when you have a multiple implementation for the same functionality, in this case I think probably you have learned into the basics of the programming as well, अपन एक interface use करते हैं, then we use a multiple implementation. So now in the user use case we will accept the user repository as a dependency. Okay, this one. So अभी क्या होगा, हमको actual implementation नहीं पास कर रहे हैं, हम just interface पास कर रहे हैं. Whatever the actual implementation you can provide at a runtime. because this implements this interface. तो जहां पर ये टाइप एक्सेप्ट होगा वहां पर ये भी होगा, राइट, बिकॉज दिस इंप्लीमेंट्स दिस इंटरफेस। तो ये एक बात हो गई। दूसरी बात, मान लो टेस्टिंग कर रहे हो आप, एंड इफ यू यूज एन इंटरफेस वाला अप्रोच, तो टेस्टिंग के लिए आप एक बना दो टेस्ट यूजर रेपोजिटरी। टेस्ट यूजर रेपोजिटरी, इस रेपोजिटरी में क्या होगा, जब उसमें आप ये मेथड इंप्लीमेंट करोगे गेट यूजर, तो उसमें आप जस्ट रैंडम आप रैंडम लिस्ट बना के फिर उसको रिटर्न कर दो। यू डोंट नीड टू एक्चुअली इंसर्ट द यूजर, गेट द यूजर। टेस्टिंग के लिए आप रैंडम यूजर्स लिस्ट कर दो, ठीक है। तो डिपेंडेंसी आपकी एक ही है यूजर यूज केस में। सी यूजर यूज केस में डिपेंडेंसी आपकी एक ही है, दैट इज यूजर रेपोजिटरी। बट बेस्ड ऑन द रिक्वायरमेंट यू आर प्रोवाइडिंग द मल्टीपल इंप्लीमेंटेशन। जहां पर इसकी जरूरत है ये प्रोवाइड करो, जहां पर इसकी है ये प्रोवाइड करो, एंड जहां पर इसकी जरूरत है इसको प्रोवाइड करो। तो दिस इज द बेनिफिट्स ऑफ हैविंग द इंटरफेस बेस्ड इंप्लीमेंटेशन। ओके,
यस सर। और इसको ही लूज कपलिंग बोलते हैं?
सॉरी,
इसको ही सर फिर लूज कपलिंग आप बोल रहे थे ना, एक बार पहले बता रहे थे, लूज कपलिंग इसी को कहते हैं?
sort of you can say, because it does not actually depends on the implementation. Okay, it does not depends on the actual implementation, it depends on the abstraction, that is, sorry, interface. So sort of you can say ki there is no tight coupling between these classes.
Okay.
Okay, any question? I think someone else had raised the hand as well.
Yeah, I raised, but yeah, not clear. But I have one doubt.
Yes,
So,
please.
like you said about the use case, like we generally don't prefer. But is it like let's say there are multiple activities or multiple fragments which are using the same view model. So for separation of concern, we can use use cases so that our view model do not get bloated. Is it like?
No. So yeah, so view model does not sits between, sorry, use case does not sits between view model and the activity. So even if you have multiple activities or a view model, it separate sits between VM and a repo.
Yeah,
So
so that so when
yes,
either we are making an API call or from the local DB or from anywhere else.
uh,
So from the view model, let's say from fragment, we are accessing different same view model but different use cases. So let's say we have two fragments. One is for profile view and one is for home screen,
okay,
which
okay,
have we on which is implemented on the same activity. So let's say
okay.
we are switching fragments. So and it has some different use cases. So in that case, this is logical to use case, right? So that our
Yeah,
view model do not get bloated. I'm not sure. I'm just asking.
Okay, so the
Mm.
to put it simply, if though two reasons, there could be a two reasons to use a use case. The one being, if you are using multiple things same time and you want to reduce the duplicacy, that is one thing you can do. And again, as you ask to make it we want to avoid it becoming a blotty, right? So even in this case, if you want to let's say if you are using these things for single time only, okay, there is no multiple use case. But if you are using the logic in a view model, that is a too complex. So even in this case, you can go for the use cases. You can just extract out your logic into use case and then use into view model. So your view model will be more clearer.
Okay, got it. Thanks.
Awesome. Okay, I think probably, yeah, it's as you can see, the domain layer is responsible for encapsulating complex business logic. So if you want to make your VM clear, you want to make it looks clean, then yes, that complex logic can be delegated to the use cases. MVVM arc, probably Android dev. I'll share the official documentation links. And yes, folks, please try to have a habit of reading the official documentation. So the documentation for the Android is a very nice, and they contains a lot of information which you won't find into single tutorials. Okay, so if you don't have any habit, please make sure you give it some time and try to learn how to read from the official documentation, because this is your best friend. Tutorials will may contain some information, may not, but the official documentation is the first thing is it looks nice, pretty, right? And the second, it contains all the information that you need to know. So you would be very proficient once you learn reading the official documentation. Cool. So you can go and have a look. Any more questions around it? MVVM architecture or anything? No more question, right? It seems. Yes, Dhruv, please.
सर वो हम थोड़ी देर पहले एक्टिविटी से आप बता रहे थे ना, व्यू मॉडल को कॉल नहीं कर सकते हैं डायरेक्टली, वो बताओगे क्यों नहीं कर सकते हैं?
हाँ, तो व्यू मॉडल का ये इश्यू है अभी, आई थिंक देयर इज सम डिपेंडेंसी इश्यू, तो वो व्यू मॉडल ठीक से बना नहीं है। आई जस्ट हैव अ लुक एंड देन आई फिक्स इट आउट। तो वो अभी ये अभी बना नहीं है, तो आई फिक्स इट आउट एंड देन आई शो यू हाउ टू एक्चुअली कंस्ट्रक्ट द वीएम।
हाँ, नहीं वो तो कोई बात नहीं, बट मैं ये पूछ रहा
ओके।
था कि यहाँ से ऐसे क्यों नहीं कर सकते हैं? जैसे अभी यहाँ पे व्यू मॉडल आपने अभी किया है ना, आप कह रहे
हाँ
थे कि ऐसे नहीं कर, ऐसे हो नहीं पाता, तो ऐसे क्यों नहीं हो पाता?
हाँ, हो नहीं पाता बिकॉज उसके लिए द रिस्पॉन्सिबल थिंग्स इज देर इज अ कंसेप्ट कॉल्ड व्यू मॉडल के साथ देर आर टू इंपॉर्टेंट कंसेप्ट, व्यू मॉडल स्टोर एंड व्यू मॉडल स्टोर ऑनर। तो व्यू मॉडल स्टोर ऑनर कोई भी यूआई होता है जो इंप्लीमेंट करता है व्यू मॉडल स्टोर को, ठीक है। तो व्यू मॉडल स्टोर होता है, एक व्यू मॉडल स्टोर ओनर होता है, एंड व्यू मॉडल तीसरा होता है प्रोवाइडर, ठीक है। तो उसके लिए इंटरनली वी हैव सेड कि राइट कि व्यू मॉडल विल सर्वाइव द कॉन्फ़िगरेशन चेंजेस। तो उसको अगर कॉन्फ़िगरेशन चेंजेस करना है तो इंटरनली उसको ऐसे इंप्लीमेंट करना है कि इट इज गेट अटैच टू सर्टेन एक्टिविटी। ओके, सो अगर आप ऐसे इंप्लीमेंट करोगे तो यू मे फॉरगेट दैट ओके नाउ एज ऑफ नाउ इट्स नॉट अटैच टू एनी एक्टिविटी, बट आपके पास डायरेक्ट एक्सेस नहीं है अगर, and you need to implement something like this, so this class will make sure that your view model is get attached to your view model store owner. So in this case it will survive the configuration changes. So to provide this attachment logics and all these things, that is why we have to use a view model provider.
मतलब
Okay, so
अभी
basically it is adding more logic of attaching your view model to your activity and registering it into the view model store, and those logic is going on behind the scene.
ओके, अभी यानी कि इसका मतलब अगर अभी हम रन कर दें और तो फिर वो कॉन्फ़िगरेशन चेंजेस को वो नहीं कर पाएगा।
हाँ हाँ, वो फिर वो नहीं कर पाएगा। बेसिकली बना ही नहीं है एक्चुअली व्यू मॉडल, इट सेम्स, because otherwise it will just simply give an error that okay you cannot directly instantiate your view model, you cannot instantiate your view model, something like this.
ओके
Okay, I'll figure it out and then I'll have a look.
ओके ओके सर।
Awesome. Any more question? It seems no. Anyone has question, please feel free to ask. Cool then. Yes.
Yes. Yeah, like Android view model is same or view model or little different? Like what is the different? Little like some interview ask question like
Right. This is the favorite questions of the interviewers. So
yeah.
what happens is this view model, again, see, view model should not be concerned about the view. So view model should not have any instance of the activity or fragments or composable, whatever. If it contains, this is a memory leak. If it contains any instance, for example, context. Context is a view, right? Context is a view, that is sorry, this one. Well, context, this context is again view, sort of a view, because activity has context, fragment has, and all this view has a context. So if you use a context in a view model, see, you can see this fields leaks a context object, right? So this is a memory leak. You should not never pass any context to your view model. Okay, because this is a memory leak, is an issue. We will understand these things in more details with the memory leaks, but this is memory leak. So now it's not that you never need context. Okay, there might be legit use cases where you will need context. Okay, in a view model, for example, if you use a localized string, so how we will get it? We will get context dot a get string, right? We will use a context dot a get strings, and here you write your r dot string dot string name, whatever. Okay, so there might be use case that you need to use these things for getting the strings, or for whatever reasons. There might be legit use case where you need a context, but if you simply pass this context directly, activity level context, that means it's a memory leak. So what you can do, instead of the view model, you can use Android view model. What it does, it provides an access to application object. Okay, so this, from the application, it provides you an access to application object. So from the application you will have an access to context as well. Okay, so application extend the context wrapper. So if you, where did it went? This one, yes. So if what you need to do, in this case, you need to pass the application, and you need to pass your application object. Okay, so this application contains the application data, it contains the context, right? Base context or application context, whatever, application context. So now you can use a context dot a get string, right? So with the help of the Android view model, you are able to use the context. So now the next question, if you explain this, okay, you understood these things, why do we need these things?
Yes.
Okay, so basically the main things of the Android. Yes, please.
Yes, for memory leak problem. If you separate using the using that.
Yes, the main benefits of using the Android view model is to get the context. Now the next question interviewer may ask is, why this does not leak and does not create a memory leak. If you do it yourself, then it is leaking a memory. If you do pass an application object, why this does not leak a memory? So the answer is, if you pass a context, there are two types of a context in Android: application context and activity context. So activity context will be separate for each activity. This is what you are passing here. This is what you are passing, that is activity context. And the active application context will be, there will be only one object of the application throughout the life cycle of your application. Okay, so if you pass this activity context, there might be possible that your activity get destroyed, you move to the next activity, but this refers to the previous activity, which will lead to the memory leak. But in your application, there will be only single instance of the application object. So even if you move from one activity to one fragment, other activity, it doesn't matter. There will be only one and one instance of the application object. So this is why it won't link the memory. Okay.
Thank you.
Cool. And yes, again, someone, if you feel that okay, Hindi is your preferred language, please feel free to do so. Because it doesn't make sense, right? I continue speaking in English, but if you feel more comfortable for everyone, feel free to do so. I'll explain in Hindi as well. Yes, Usha, please.
Yeah, we have a shared view model as well, right? So what is the use of it exactly?
So shared view model, there is no things like a shared view model class sort of things. But what we call shared view model is when we want to use the same view model logic in a multiple views. For example, you have a multiple views. This is view 1 and this is your view 2. Okay, so what you want is you want some functionality from this view model in both of this view. So in this case, what you can do, you can reuse the same view model in a multiple views. So this is known as a shared view model. We are sharing the view model between multiple views. So this is known as a shared view model. There is no such things at the code level. It's just that you sort of where it is. Yes, you just sort of use the same view model in a multiple views.
Okay. Okay, if the interviewer asks like a type of view model, can we answer both like view model and a view model or anything else?
Yes, if they ask the types of the view model, you can tell just a view model and Android view model. Shared view model you can mention for extra context, but you can explain that yes, there is no concept like shared view model at a code level. It's just that we want to just reuse the view model functionality across multiple views.
Okay. Okay, and one more thing, like if we are like
Yes.
if you want to pass data between fragments, can we use the view model?
Yes, if you want to pass a data between fragments, then the appropriate option would be to use a shared view model. That is, use the same view, use a view model. In the view model, have a observable, for example, stat flow or live data, or something from RX as well. You use a observable, and then use this view model across multiple fragments. So even if one fragments update the observable, as it is observable, the next fragments will get the value. So shared view model is an ideal option to use for the sharing the data between fragments.
Yep. Thanks, Alice.
Cool. Yep. And yeah, thanks for pointing it out. It's another favorite question of the interviewers. How do you share the data between two fragments? Uh, cool. Any more questions around it? Probably we are not going to cover fragments and all these things. Just pardon me because the focus is on compose. So I have explained activities, view models we will see, and we will then yeah, tomorrow is a day after tomorrow is a coroutines. So coroutines one would be interesting. We will learn from the pure Kotlin perspective first. Okay, then we will move on to the Android, because coroutines is again Kotlin concept. So we will learn from the pure Kotlin, no Android Studio, nothing else, just JetBrains IDE. And then I'll show you Android things as well. And probably today everyone or most of you will complete the assignment. So we will do assignment evaluation on Wednesday. We will basically go through 3-4 assignments and provides my feedbacks. If you have not done it, please feel free to do so. And thank you everyone for joining. Have a good night, take care, and bye bye.
Thank you.